Now start recording. Okay, now we proceed with question 23. Determine the change in the pH if 1 centimeter cubic of 1 molar hydrochloric acid is added. So now our buffer with pH 4.84 just now is added with another strong acid, which is hydrochloric acid. Is added to 100 centimeter cubic, okay, of the buffer solution. So buffer ni dia tadi dia kata 1 liter kan, 1 liter. So sekarang dia bukan 1 liter, kita ambil buffer yang sama tapi kita ambil buffer tu 100 ml saja. Okay, kemudian masukkan 1 cm cubic which is 1 ml. 1 cm cubic is equal to 1 ml of what do we call hydrochloric acid. Okay, 1 ml HCl. Okay. Jadi kita nak cari pH change. What is the pH when we add 1 cm cubic of strong acid to this buffer solution? Okay. So first of all, we need to find the number of mole of the number of mole of salt and acid in the presence of 100 ml. Okay, tadi yang kita dapat number of mole acid dan salt ni 0. Mana tak number of mole? This one. Okay, so this number of mole is the mole of salt present in 1 liter. In 1 liter buffer. But we take out 100 ml of the original buffer, which is 100 centimeter cubic. Now, how many mole of salt and how many mole of weak acid presents in this 100 centimeter cubic of this buffer? So we need to find the number of mole of ethanoate, the salt and the weak acid. So finally, we get the number of mole of salt is 0.0249 and 0.02. So jangan keliru, this is the number of mole of the salt and the weak acid present in 100 ml buffer. Okay, after that, we calculate the amount of mole, the number of mole of the acid added. Okay, so the volume and concentration given. So molarity, volume, so the number of strong acid added. Okay, so this one HCl added. Okay. Sekarang kita nak buat the number of mole yang kita nak cari perbezaan dia. Okay, so initial mole, the salt present is 0.0249 and then acid added is 1 exponent negative 3. 0.001, betul tak? 1 mole. Okay, and then weak acid, the number of mole weak acid is this one, 0.02 mole. Okay, so now all of the acid change in mole. Okay, all of the acid added is being neutralized by the base component. Okay, mana tadi? So kita masukkan H+, spesies mana yang dalam buffer ni akan meneutralkan H+ added tu. So that is the salt. Okay, the base component. So kita dah melalui tutorial hour 4. Sekejap ada orang datang pula. Okay, so kesemua asid yang ditambah tu dineutralkan oleh base component buffer tu, iaitu ethanoic ion. Okay, to produce CH3COOH. So this amount is being neutralized, all of them. Okay, so banyak mana yang akan ethanoic ion akan reduce? Same amount, which is 0.001. So this one will increase, and then they are forming ethanoic acid, so increase by 0.00. The final concentration, final number of mole will be 0.0239. This one 0, finish, and 0.021. Okay, and then at equilibrium, we try to find the molarity in equilibrium because we are going to substitute into the Henderson-Hasselbalch equation. .0239 over the asalnya adalah volume dia adalah 100 ml. Sekarang kita tambah 1 ml HCl strong acid. So total volume is 101 ml. Okay, 0.101. So the concentration will be 0.237. Another one is 0.021 over 0.101. So it is 0.208. Okay, this is the molarity. Molarity of weak acid and weak base. Okay. So sampai sini ada nak tanya soalan? So everyone clear? Okay. So daripada 100 ml tadi, kita telah mengira concentration yang baru setelah kita tambah strong acid, which is concentration of the salt and the concentration of the weak acid. So now we need to calculate the pH. What is the pH when 1 ml strong acid added? So concentration log 1.8 exponent -5 log concentration salt. So the salt is 0.237 over concentration. Okay, so originally it is 4.84. So when we add acid, it decrease to be 4.8. So logik kan dia decrease sebab kita tambah acid. So tambah acid, dia decrease. And then dia tanya what is the change. Okay, how much is this change? It is 0.04. Changes in pH. Okay, so walaupun ditambah strong acid tapi dia mampu untuk maintain dia punya pH. Dia akan turun tetapi sangat sedikit. Okay, sekarang kita pergi ke soalan 24. 500 ml 0.1 molar hydrazinium solution was added to 5 ml of solution hydrazine. What is the pH of the mixture? Okay, sekarang kita nak analyze mixture dia apa. Okay, kita ada satu solution 5 ml 0.1 molar N2H5Cl plus 5 ml 0.2 molar 0.2 hydrazine. Okay, so something kalau you nampak N2H4 and then dia punya ion ni lebih kurang sama dengan ni. So we believe that this is the weak, the salt, and this is the weak base. Okay, so dia akan hasilkan buffer. Kalau 500 ml dah 1 liter. So dalam buffer ini terdiri daripada N2H5 plus and N2H4. So this is the salt and this is weak base. So dia dah jadi basic buffer. Okay. Sedangkan soalan ni dia tak mention pun buffer kan. Tiba-tiba dia minta kita cari pH. So penting untuk kita recognize this is buffer or this is weak acid only or this is strong acid solution only. Okay. Remember yang yesterday I've mentioned to you, we have 3 conditions, whether it is strong acid, strong base, or second condition, it involve only weak acid or weak base. Okay, masih kira pH juga. And ketiga adalah buffer, sama ada acidic buffer ataupun basic buffer. So penting untuk pelajar identify these 3 situation because it will determine what formula you are going to use and what is the proper step to do. So ini kita dah boleh recognize dia adalah buffer solution, basic buffer. So apa yang kita perlu buat adalah kita nak kira pH of the mixture. Okay, so we understand that okay, this is buffer pH, buffer. So basic buffer kita kena kira PO, H, negative log KB plus log salt there N2H5 plus weak base. Okay, tetapi kita nak cari, so sekarang our aim is to find the concentration of this salt and the concentration of the weak base. So initially, there are 5 ml 0.1 molar. Ni initial. Tapi sekarang, final dia dah jadi 1 liter. So kita boleh guna M1 V1 equal to M2 V2. M1 V1 is the original before mixing, M2 V2 is after mixing. Okay. So kita cari mole bagi salt dahulu. Okay. For the salt, initially it is 0.1 molar times liter dia 0.5 liter equal to molarity yang baru tak tahu, volume dia 1 liter. So molarity baru bagi salt adalah 0.05 molar. Okay. So that one is salt. Kalau weak base, initially it is 0.5 liter times 0.2 molar equal to molarity yang baru, volume dia 1 liter. So molarity yang baru adalah 0.1 molar. Okay. So yang kita sedang cari ni adalah molarity salt, molarity weak base. Setelah kita campurkan yang ni, yang dah jadi buffer. Okay. Then, boleh tak kita substitute sekarang ke dalam Henderson-Hasselbalch? Dia kata pH of the mixture means the pH of the basic buffer. So, kita boleh substitute negative log KB dia 1.7 exponent negative 7 plus log concentration salt 0.05 over 0.1. So, you dapat the POH should be 6.47. So, pH adalah 14 tolak POH 6.47. So 14 tolak ni berapa? 7.53. That means this buffer, pH of this buffer is 7.53 pH. Okay. pH, let's see. Alright, ada soalan nak tanya soalan ni? Yang confused ke mana-mana part? Tak ada? So, now we continue 24B. By writing equation, explain what would happen to the pH of the solution when a small amount of strong acid or strong base is added to the solution. Okay. Sekarang kalau kita kata small amount of strong acid added, so kita tunjukkan acid added. So komponen mana yang kita akan neutralize the acid added? Remember, I repeat just now, we have the N2H5 plus is the salt component and the weak base is N2H4. So dia mesti ada dua komponen dalam satu buffer. Tak kisahlah acidic buffer atau basic buffer, dia mesti ada dua komponen iaitu komponen acid dan komponen base. Sekarang kita adalah, condition buffer kita adalah basic buffer. But still we have these two component. Okay. This salt is the acidic component and then the weak base is the base component. Okay, macam mana kita tentukan ini adalah base component? Kita tengok ni, H5, dia ada banyak hydrogen kan. So as an acid, it tend to donate the H. So donating H, sebab banyak H, dia akan donate H. Donate H adalah acid. Sekarang N2H4, nitrogen ni ada lone pair kan. Okay, so ni semua neutral. Dia boleh buat apa? Tendensi dia untuk menerima proton tu lebih mudah. Sebab nitrogen ni ada lone pair. So accepting proton is a base. Remember the definition of the Bronsted-Lowry definition acid base. Acid according to Bronsted-Lowry is the species that donate hydrogen or donate proton, while base is species that easily accepting the proton. Okay, now since we identify the component, if we add acid, then we are going to react with the base component of the buffer. So the acid added is being neutralized by the base and the concentration of base is decreased, concentration of salt increase. But N2H4, we add with the H plus added, producing this one. Okay. Therefore, addition of the H plus should reduce the pH, but the pH reduces does not much affected, does not decrease too much. Next, masih yang sama kalau strong base is added. So we put the OH minus. Kalau kita letak OH minus, of course the acidic component akan neutralize the base added. So this is the acidic component, the salt of the base. And then when base is added, base is neutralized by the OH minus. So the concentration of OH minus completely neutralized by the base component and increase the concentration of N2H4. Concentration salt berkurang. So ini dah tak ada dah. Okay, because it's been neutralized. Then pH dia sepatutnya tinggi because adding this one, but it is slightly increased. Okay, or we call it the pH does not much affected. Okay, now we continue to question 25. Okay, now let's analyze this question. 1 ml of 0.1 molar sodium hydroxide, this is strong base, was added to 1 ml of buffer solution containing 0.15 sodium ethanoate and 0.1 ethanoic acid. Now, is this solution is really a buffer solution? So kita kena tak boleh percaya bulat-bulat pada soalan tu. Dia kata buffer. Now let us check whether it's buffer or not. So we have sodium ethanoate, okay, and then this is ethanoic acid. So it is weak acid and this is the salt. So it is buffer solution. So what kind of buffer? It is acidic buffer. Okay, so dalam ni ada apa? Dalam buffer kita ni ada ethanoic acid and then kita ada sodium ethanoate. Okay. So we just focus on the presence of weak acid and the salt. Okay. Now we need to identify which one is the acid component and the base component. So this is the acid component. Acid buat apa? Donate H. COO minus is a base component. Buat apa base? Receive hydrogen. Okay. Now dia tanya apa? Calculate the change in pH of the solution. Okay. Original pH. So kita kena cari what is the pH of this buffer. pH dia berapa dahulu. Lepas tu barulah kita cari pH setelah kita tambah 1 ml strong base. So it is originally 1 liter. So ni 1 liter. Okay. Sekarang buffer kita ni dah tak jadi 1 buffer dah. 1 liter. So 1 liter plus 1 ml of OH minus added. So dalam ni ada CH3COOH, CH3COO minus dan ada OH minus added. Okay. So kita nak tahu pH setelah kita tambah base. Nampak? So yang kita nak cari adalah pH buffer, pH setelah tambah base. Okay, sebab dia tanya change kan. So kita kena cari initial pH. Okay. Sebelum kita tambah, before addition of ni, kita kira dulu pH buffer. pH initial buffer. Where pH is negative. pKa, negative log Ka. Negative log, ni saya tak tulis formula tak apa kan? Kamu faham tak? Log, ke kena tulis formula juga?
Formula.
Tak cepat kan? Macam dah expert dah, malas lah nak tulis formula. Okay, tak apa, saya tunjuk lah. pKa tambah log salt tambah log weak acid. Negative log pKa is negative log Ka 1.8 exponent negative 5. And then this one is plus log salt, concentration of salt. We have the concentration of salt. 0.15 molar, 0.1. 0.15 divided by 0.1. So it would be, what's that? 4.19. 4.921 pH there. Okay, so remember initial. Okay, ini sebelum kita tambah. Okay, so once we add, lama tak cukup okay ni. Once we add, volume dia dah jadi apa tadi? Volume dia dah jadi 1 liter plus 1 ml. So it will be around 1.001 liter. The new volume. Okay. So adakah mol sebelum dan selepas tu akan bertambah? Okay. Initially the number of mole, okay, kita pun repeat proses yang sama macam soalan 23-24 tadi. Okay. Ini adalah original daripada buffer. Okay. From buffer. Okay. It is concentration times volume, dapat 0.15 mole and then 0.1 mole of acid and salt. Okay. Tambahkan base base yang di added, strong base added, it is 0.0001 mole. Sekarang kita buat unstable. Unstable kita, once kita tambah OH minus, spesies mana yang akan react? Kita tambah OH minus, spesies mana yang akan neutralize this OH minus? Of course, yang ni kan. Where dia akan keluarkan dia punya H ni. Dan dia akan neutralize this OH minus. So, sebab tu kita tulis acid komponen akan neutralize OH minus to be salah ni. Ni akan keluarkan this one kan. So, ini akan jadi CH3COO minus. Okay. So initially as the number of mole acid yang memang sedia ada adalah 0.1 mole. Kemudian base yang ditambah adalah 1 exponent -4 mole. Ni. Kemudian originally kita ada salt sebanyak 0.15. This one. Okay. Now semua acid yang ditambah ini telah dineutralkan. At the end habis. Jadi, amount yang dineutralkan ini, base yang dineutralkan akan sama dengan amount acid yang digunakan. Banyak mana base yang kita letak, banyak itulah kita akan gunakan acid itu. So, acid akan berkurang sebab dia nak neutralizekan OH minus. Finally, the concentration of acid is 0.999 and then the combination of this one and this one will produce salt. So original salt banyak ni, sekarang bertambah sebanyak ini dan final number of mole of salt is this one, 0.1501. Okay, so since kita dah dapat concentration of weak acid and weak base dalam solution buffer tu, so kita cari molarity dia. The number of mole over the new volume. Kenapa volume dia daripada 1 liter ni menjadi 1.001? Because this is one that is the volume of the of the OH minus. Okay, so molarity is mole over volume. Ini pun sama, molarity equal to mole over volume. Okay, then kita pun dah dapat dah, that is the concentration of salt and weak acid after addition the strong base. Okay, sekarang nak cari pH, pakai Henderson-Hasselbalch equation yang pH. Okay, why sometimes Henderson-Hasselbalch dia adalah pH, sometimes pOH. It depends on your buffer. So this buffer is acidic buffer, sebab tu kita pakai pH. Just now, Henderson-Hasselbalch yang kita pakai adalah pOH because it is basic buffer. Okay, so itu kena pandai ya. Okay, so substitute pH equal to pKa log salt over ni. Substitute everything, we dapat 4.92. Okay. Just now, kalau buffer sahaja 4.92, 1. Now, addition of small amount of 1 ml of strong base, dia akan menghasilkan pH dia 4.922. Okay, so the changes is only 0.001. Okay, so we have proved quantitatively or practically we proved that the addition of small amount of base won't change the pH of the buffer too much. Okay, or the pH should increase but not increase significantly. So naik 0.001 maksudnya pH maintain lah, tak ada masalah pun. Kan? Okay. Yang you susah payah belajar buffer ni, dekat mana? Dekat mana dia wujud? Kenapa diciptakan sistem buffer ni? Boleh tengok dalam perut kita ada asid kan. So bila kita tapi dalam perut kita buffer ke? Sebab perut kita what kind of acid? Ni bio student kan. Student saya semua physical student. So kalau cakap mana tak faham je. Ataupun buat-buat tak faham. Okay, you bio student, dalam perut ada asid apa?
Hydrochloric acid.
So that one is strong acid, right? So dia tak boleh jadi buffer lah kan. Kat mana lagi? Dalam badan kita ada darah kan. So we need to maintain our pH of our blood. So nanti jadi doktor, you kena tengok lah pH darah patient tu berasid ke, to base to acidic. So darah pun adalah sistem buffer juga. So macam mana it works, that is your responsibility lah, you baca lah sendiri ya. Tapi nak bagi tahulah nanti maksudnya konsep biology tu dia is application of some application of buffer system. Tak adalah terkejut nanti. Maksudnya nak cakap tak boleh abaikan buffer ni walaupun tak suka kimia, walaupun suka bio. Bukan kamu lah yang tak suka bio, yang tak suka kimia ni, orang lain. Baik-baik. Okay. Sekejap. You bio student ke? Bukan. You bukan H kan? Sorry. You physical student ke? Then I realise sekarang salah orang pula. Okay. We just take a break. Sekejap. Saya nak ajar KS2. Stop recording.